Hello, algebra students, and today we are going to learn how to factor by grouping. Now, factoring by grouping is actually really simple. Sometimes it gives students a little bit of a tough time, but remember, we learned how to factor by GCF. In fact, let's just review. Let's say this problem here, we have 25x squared plus 5x, and we are going to factor it using the GCF. So I look for the greatest common factor between 25x squared and 5x. Looks like my GCF in this case is going to be a 5x. So I bring a 5x out front of the quantity. Dividing this term by 5x gets me 5x. Dividing this term by 5x gets me a positive 1. And there you go. I just factored using the GCF. Well, to factor by grouping, two things you need to know. The first thing is there's usually 4 or 6 terms, right? 4 or 6 terms. Um, there's a special case where you can have 3 and then you can turn it into 4, but 4 or 6 terms. Okay. The second thing you need to know is that you're going to GCF 3 times. That's all you're going to do. That's all factoring by grouping is. We're going to GCF, we're going to GCF again, and then we're going to GCF one more time. So let's see how this works. Okay. Well, I've told you there's got to be 4 terms, and look, there's 1, 2, 3, 4 terms, right? Okay, so since there's 4 terms, I'm going to try factoring by grouping. Now, I've got to group together 2 pairs of terms. I've got to make sure the pairs I put together have a GCF. Is there a GCF between x squared and 3xy? There sure is. So I'm going to put them together. All right. Is there a GCF between 4xz and 12yz? Yeah, there sure is. So I'm going to put them together. All right, now here comes the first GCF. I'm going to GCF this quantity, and it looks like the GCF is going to be x. So I'm going to pull an x out of this quantity, leaving behind an x plus a 3y, right? All I did was GCF the first quantity. There was GCF number 1. Okay, now I'm going to come over here and GCF this quantity. Looks like my GCF might be a 4z, I think. So I'm going to pull out a 4z, and I'll be left with an x, and 12 divided by 4 is 3, and I take the z out, so there's a y left. Do you notice anything? There was my second GCF. Do you notice anything? Look at this. Sorry, wrong button. Get my highlighter out. Do you see this guy and this guy? What do you know? They're common, aren't they? The x quantity of x plus 3 is showing up in both groups. And in fact, this is multiplication, yes? And so is this. So that means the quantity of x plus 3 is a factor of both terms. And it shows up in both, so therefore it's a common factor. So here comes my third GCF. And this is the easy part that screws kids up, but it's so simple. This highlighted thing, it gets GCF'd. I'm going to pull an x plus 3 out of the first term. And what's left there? Just a plain old x. I pull the GCF out of the second term right here. What's left? A 4z. And there you go. That's my third GCF, and I'm done. So I GCF this first group, I GCF the second group, and then I found a common factor in the next line and GCF'd one more time. That's my third GCF. Pretty simple stuff. All you're doing is GCF, GCF, and GCF one more time. Let's try it on this one. Okay, remember, first we need to group our 4 terms together into 2 pairs, but we've got to make sure the pairs have a GCF. Is there a GCF between 10xy and 35x? There is. Is there a GCF, other than 1 that is, between 6y and 21? There sure is. So I'm going to group the first two, and I'm going to group the second two. Okay. Now, I'm going to pull out the GCF, which I think would be a 5x, and I'm going to leave behind a 2y plus a 7. Here, I'm going to GCF a 3. Pull out a 3, and I'm going to get 2y plus 7. Look at that. Oh my goodness, this is magical. Nah, it's mathical. All right, look at that. A 2y plus 7 in a quantity and a 2y plus 7 in a quantity. All we're going to do, are you going to catch this, Haley? Because this is really easy stuff, sweetie. All we're going to do is pull out a 2y plus 7, leaving behind a 5x plus 3. And there we go. All done. I GCF'd once, I GCF'd twice, and I GCF'd a third time. All right. Let's look at this one. Now, there's 4 terms. I'm going to look and see. Is there a GCF between 12y and 2x? Yes, 2. And of course, then whenever I'm talking about greatest common factor, I'm not considering 1. 1 is never a consideration because dividing by 1 doesn't change anything. All right, I've got a 24 plus xy. I don't see a GCF in this pair. I'm going to rewrite this so that I have GCFs in both pairs. There are probably more than one way to rewrite it. I think I'm going to start with the 2x term, and then I'm going to put the plus xy term. All right. Then I'm going to put the 12y. I'll put the 12y and the 24. Do I have a GCF between these two? I sure do. Do I have a GCF between these two? I sure do. So I'm going to group the first pair together, the second pair together, and now it's time to GCF. Looks like the GCF of the first quantity is x, and I'm going to be left with a 2 plus y. The GCF of the second quantity is going to be 12, leaving me a y plus a 2. Did I get a quantity with the same terms in it? 2 plus y, y plus 2. What do you think, Kyle? Are they the same thing? Yeah, they sure are. Therefore, they're a common factor. So I'm going to GCF one more time. So I'm going to pull out a y plus 2, and then I'll be left with x plus 12. And there's your answer. I GCF once, I GCF twice, and I GCF a third time when I pulled out the y plus 2. All right, one more example, and that'll be it for tonight. All right, hopefully you're watching this one, Marina. Okay, I'm going to look and see. Do I have a GCF between 15x and negative 14y? No, I don't see a GCF there. So I'm going to have to rewrite these terms. Maybe I'll leave the 15x first. And when I look and see, I've got this 35. I know it has a common factor with 15. I'm going to bring the 35 next. And then I'm going to go with a negative 14y plus 6y. And I think there's something wrong in this problem. Hold on. Okay, I decided to change that problem. Hopefully you won't hold it against me. I must have made a mistake when I made my original. Good thing I caught it before I got too far into it. So let's start again with this one. 15x plus 7z minus 3xz minus 35. And again, I look at the first two terms, and I don't see a GCF. So I'm going to rewrite this problem. And I'm going to leave the 15x out front like I thought. And excuse me, I have two choices. I could put the minus 3xz with the 15, because there'd be a GCF there, or the minus 35. I'm going to go ahead and do the minus 35. And then I'm going to write the minus 3xz next and the plus 7z. And again, there's lots of different ways to write it. But I've got to make sure I've got a GCF in both pairs. Okay, so I'm going to group these. Now you have to be careful here. You see this negative? He belongs to the 3. So I'm going to grab him, but I have to insert an addition sign there. If I don't, I've changed it to a FOIL problem. Now, I didn't do that on any of these examples because the 12 is already positive. So you could argue I did grab the positive, but I don't waste my time to write it down. Okay? In this case, the 6 is already positive, so I just put parentheses around and put a plus. Okay, so I'm really putting a plus between the quantity all the time. If there's a negative sign, I have to grab it. Okay, my GCF here looks like it's going to be 5. Pull out a 5, and I'll be left with a 3x and a minus 7. Now, here my GCF is z, so I'm going to pull out a z. And I'll be left with a negative 3x plus 7. Hey, that doesn't work. Those don't match. Something's wrong. Because, look, I got 3x minus 7 and negative 3x plus 7. I mean, they're not the same thing. If you think they are, then you're trying to tell me that 3 minus 7 equals negative 3 plus 7. Oops, 7. And I beg to differ, because this one is negative 4 and this one is positive 4, and they definitely are not equal to each other. So, am I done? Am I stuck? Can this one not be done? Is there no solution? Like many of you want to yell, no solution, it can't be done. Ha ha! I fooled you. That is not the case. Anybody have an idea of what I might have done instead of pulling out a z? I'll bet Cheyenne has an idea. I'll bet she's thinking I could pull out a negative z. If I pull a negative out, then this becomes a positive, and then that 7 becomes a negative. And look at that. I'm going to get rid of this plus sign because I don't like double signing. I have a 3x minus 7 in the first quantity, and I have a 3x minus 7 in the second quantity. So now we're ready to GCF our third time. And this third one is the easiest because I take that highlighted quantity, and then I'm left with 5 minus z. And that's it. That's all there is to it. All right, so hopefully by now you have a pretty good understanding about how to factor by grouping. We will get some practice in class tomorrow. Remember, it usually happens with 4 or 6 terms. You tend to not see the 6-term one so much. And you're just GCFing 3 times. All right, Mr. Lawrence signing off. Have a good night, everybody.